Hi, welcome to Exam Comrade. Today we'll see the UPSC CSAT analysis. Except the English portion, we'll cover maths and logical reasoning portion today. Okay, this is set C. The question is: a box contains 14 black balls, 20 blue balls. This is black. 20 blue balls, 26 green, 28 yellow, 38 red, 54 white balls. Okay, the total number of balls is 4 plus 6 10, 10 plus 20 30, 3 2 5 7 10 15 3 8. So there are total 180 balls. The first statement is the smallest number of n such that any ball drawn from the box randomly must contain one full group of at least one color. Okay, so there are how many colors? There are total 6 colors. 6 colors. To find the answer for first step, what I do is I'll keep one ball aside. Let's say one black ball, one blue ball, one green ball, one yellow ball, one red ball, and one white ball. I'll keep aside, and the remaining that is 180 minus 6, 174. I remove the from the basket. So when I take the next ball from this, we are very sure that one color of ball is already covered. In 174 there are every color balls except one ball, right? So if you pick one ball from this basket, there will be one color, at least one color, which will be full. So the answer is 174 plus 1, that is 175. So the first statement is correct. The first statement is correct. Okay, what is the second statement? The smallest number of m such that any m balls drawn from the box randomly must contain at least one ball of each color is 167. Okay, so what he is saying is, if he is picking some m number of balls, must contain at least one ball of each color. So what he is saying is he has to have every color. So is asking the maximum number. So to maximize this number, we have to take the minimum number of balls, that is total is 180. If we need to max this, we need to minimize this. So this minimum, what is the possible value? That is 14, right? 14. So we have to pick one from this. So the answer is 180 minus 14 plus 1, that is 167. So the second statement is also true. Both 1 and 2 are true. Okay, let's go to next question. Okay, I think this is the very easy question of the paper. 0 is written as CHUR. Okay, then how is player written? Okay, Z means AB skip, EFG skip, RST skip, OPQ skip. So skip two letters, PQRS, RSTU, EFGH, SHU. I think this is the answer. Fourth option is the right answer. Let's go to next question. Okay, this is also one of the easy questions of the paper. It is given as $7, $9, 10 is 8. So let's add these let's add the numbers. So 7 plus 9 plus 10 is 16 plus 10 26. So that is 2 plus 6, that is 8. Okay, let's check for the other thing also. 9 11 30. 9 plus 11 is 20 30, that is 5. Okay, 11 17 21 28 49. 4 plus 9 13. Okay, So what is the value of 23 plus 4 plus 15? That is 27. 27 plus 15 is 32, 42. That is 4 plus 2, 6. That is option number A. This is also one of the easy questions. Next question is A is older than B. There are 5 statements given. This question is of data sufficiency. How many statements are required to conclude? Okay, A is older than B. This is first statement. E is the youngest. F is younger than D. F is younger than D. F is older than A. This is F is older than A. F is younger than D. So what is asked? How many statements are given and are required to determine the oldest person? Okay. So I think we need to use all the statements to conclude that D is the eldest person. So all 5 are required. 1, 2, 3, C and D are of same age. Sorry. Okay, so all 5 statements are required. Next question is there are 5 members A, B, C, D in a family. Okay, statement 1 is A and B are married couple. D is the father of C. D is the father of C. E is D's son. E is D's son. Okay, A and C are sisters. So what is the relationship between E to B? So we need to find a relation between these two persons. So first we need to join B is related to say C, A. So we need to combine these things. A is sister of C. Okay, let's have this. We have to combine these two things to establish a relation between C and D. We have to use these two statements also. So I think all the 5 statements, all the 4 statements are required. All 4 statements are not sufficient to answer the question. All 4 statements together are sufficient to answer the question. Next question. Choose the group which is different from others. 17, 37, 47, 97 all are prime. 31, 41, 53, 67 prime. 71, 73, 79, 83 prime. 83, 89, 91. 91 is 13 into 7. So not prime. So this is the answer. Let x be a positive integer such that 7x plus 96 is divisible by 6. How many values of x are possible? He's saying that 7x plus 96 is divisible by x. It implies as the 7x already is divisible by x, we'll check the divisibility rule for the 96. So 96 is divisible by x. So let's find out the factors for 96. 96 can be written as 3 into 3 3s are 3 2s 6. That is 2 power 5. 2 power 5 into 3 power 1. So the number of factors is 5 plus 1 into 1 plus 1. That is 6 into 2, 12. The answer is 12. I think these are the very easy questions, but the next part of the questions we may find it very difficult because most of the aspirants have told that the paper was very difficult. Let's see how the paper is. Okay, next question is if PQR are distinct positive number, then what is the greatest value of P plus Q plus R, P plus Q into R plus S? Okay, as this should be the largest, what we can do is PQRS as 6 7 8 9. Okay, not respectively, that is P is not equal, P is not 6. Okay. If we have x plus y is equal to 10 and we need to maximize the value of x y, what we do is we take x is equal to y is equal to 5. Let's check it. Suppose 5 into 5 is 25, whereas 6 into 4 is 24, 7 into 3 is 21. Okay, 2 into 8 is 16. So the maximum value is when x is equal to y. That means we have to make p plus q equal to r plus s. So we take pq as 6 plus 9 is equal to 7 plus 8. So the answer is 15 into 15 equal to 225. That is the answer. This is also easy question if you know the concept. The number n formed by writing n 999 times. What is the remainder if n is divided by 13? Okay. We know that xyz can be written as xyz into 1001. Okay, so this 1001 is divisible by 13. So what we can do is this 9 we have to write 99 times. Okay, so we'll split this 99 times into each block of 6. First block, second block. So we have 96 terms up to here. So 3 times remaining. Okay, this block is divisible by 13. Similarly, this block, so on up to this block is divisible by 13. What is the remaining portion is 999. Okay, this can be written as 1001 minus 2. We know that 1001 is divisible by 13. So the remainder is minus 2. Minus 2 remainder is minus 2 implies 13 minus 2, that is 11. 11 is the answer. Each digit of 9 digit is number. Each digit of a 9 digit number is 1. It is multiplied by itself. So there is a number like this. Okay, there is 1 9 times. So what is asking is sum of the digits of the number. If a, what is asking is sum of the digits of a. So yeah, we can do it by digital sum. The digital sum is 9. 9 into 9. So the answer will be a multiple of 9. Let's check the option. 64 is not a multiple of 9. 80 is not a multiple. 81 is the answer, right? Okay, you can do it directly, mark it directly. Okay, if you don't know digital sum, let's solve the problem. If you say 11 into 11, answer is 121. If we take in 2 times, this is the answer. The multiplication is 121. If we take 3 times, answer is 12321. So if we take similarly, if you take 9 times 1, the answer will be 1 2 3 4 5 6 7 8 9. This will be repeating 8 7 6 5 4 3 2 1. So we'll have up to 1 to 8 2 terms. So we are adding this digits. This is 1 plus 2 plus 3 plus 4 up to 8 into 2 plus 9. So 1 to sum of 1 to 8 is 8 into 9 by 2 plus 9. So the answer is 9 into 8 plus 1. Answer is 81. If you know the digital sum, we can directly mark. If you don't know digital sum, it may take some time to solve this. What is the sum of all digits which appear in all the integers from 10 to 100? Okay, let's write 10 to 19 here, 20 to 29, so on, 90 to 99 plus 100. Okay, if we find the unit digit sum, okay, unit sum we can write it as 1 is repeated 10 times plus now 0 to 9 plus 0 plus up to 9. So this is 9 into 10 by 2. 9 into 10 by 2. Sum of n natural numbers is n into n plus 1 by 2. So we can write 0 to 9 as 9 into 10 by 2. That is 45. Okay. Similarly, in the second row also we get 2 into 10 plus 45. 3 into 10 plus 45. So on 9 into 10 plus 45 plus 1. So we can write, we can 10 take common in this thing. You can write 10 into 1 plus 2 plus 3 plus up to 9 plus 45 here 9 times plus 1. So up 1 plus 1 plus 2 plus 3 up to 9 can be written as 9 into 10 by 2, that is 45. So 45 into 10 plus 45 into 9. So taking 45 is common. 45 into 19 plus 1. 19 5 is a 95. 19 4 is a 76. 76 plus 9, 85 plus 1, that is 856. The option is B. Okay, next question. ABCD is a square. ABCD is a square. 1 point each on AB and CD. 2 distinct points on each of BC and DA. Here is a point. Here is a point. How many distinct triangles can be drawn using any of the three? First, we have to make sure that there are no collinear points. Okay, no 3 points are collinear, so we can directly take 3 points from the available 6 points. So the answer is 6C3. 6 into 5 into 4 by 3 into 2. So answer is 20. This is also easy question. Okay, let's go to next question. There are 5 positive integers. I think there are more questions which are reasoning based. We have to analyze the things and we can then only we can answer. I think there are the formula based questions are very less in this paper. So they are more of conceptual based and analytical based. Okay, let's try to solve this problem. 3 of them are even and 2 of them are odd. Okay, P plus Q plus R plus R minus S minus T. What we can do is we can add S plus T and then remove it. So this will be, as 3 of them are even and 2 of them are odd, so this sum will be even. Odd plus odd is even. This is all are even terms, so this will be even. Even plus even minus 2 into S plus T. This S plus as S plus T is multiplied by 2, this will be always even. So the entire number will be always even. Okay, so the first option is correct. Okay, let's check for the second statement. Here it is given that 2P plus Q plus 2R minus 2S plus T. So let's take the terms which have 2 as in common. P plus R minus S plus Q plus T. This term will be always even. Okay, we don't know whether if QT both are odd or both are even. If Q plus T, we don't know whether Q is even or T is even or Q is odd or T is odd. So we cannot surely say that this statement is odd. So the only one statement is correct. Next question is, a 3-digit number ABC on multiplication with A with D gives 37 DD, where ABCD are non-zero digits. Okay, let's suppose there is a number called ABC is multiplied with D. We are getting 37 D into D. Okay, let's take the value of D as 1. Is it possible to get a 4-digit number? No, not possible. So 1 cannot be possible. 2 cannot be possible. If we take 2, the largest number possible will be less than 2000. So but the answer is somewhere more than 3000. It cannot be 2. So if we take 3, is it possible? The largest possible number will be 1000 into 3 minus 3. So this is also not possible. Let's take d is equal to 4. Okay. If we take d is equal to 4, what we get as 3744 divided by 4, that is 9 3 is 36, no, 9 4 is 30, 436, 4 3 is 12, 4 6 is 24. So the sum of digits here is 9 plus 6 15 plus 3 18. Okay, let's check for d is equal to 5. If d is equal to 4, the answer is 18. We take d is equal to 5, 5 7 35 2. Okay, the sum of digits a plus b plus c is 13. So for d is equal to 4 we are getting one answer, and for d is equal to 5 we are getting some other answer. So the answer is cannot be determined due to insufficient data. Okay. Next question is, for any choice of xyz, the 6-digit number xyz is divisible by. We have already discussed in our previous shorts also that this number is always divisible by. This number can be written as xyz into 1001. So this 1001 can be written as 13 into 11 into 7. So this number will always divisible by 13 into 11 into 7. We have already posted a few questions regarding this in our Telegram channel also. If you have not followed, you can follow Telegram channel Exam Comrade. Okay. Let's go to next question. There are 125 ideal cubes arranged in the form of a cubical block. How many cubes are surrounded by other cubes? For suppose this is the cube that we have. Okay. So what we can say is that there will be a inner cube, this one, which will be surrounded by the other cubes. Okay, so we need to find the, so this portion we have to find. So what we will do is we will remove one side, one block from this side, and one block from this side, and one block from this side, one block from this side. So the answer will be n minus 2 whole cube. So that is 5 minus 2 whole cube, 27. Next question is, how many 8-digit numbers can be formed by remaining? Okay, this is a combination, permutation and combination based questions. 8-digit number. Okay, let's take odd positions, 1 2 3 4. Okay, even positions. Okay, this is odd, 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 even, even, even. Okay, the numbers available are 11, 22, 33, 44. Okay, these are the numbers that are available. Let's take the odd position first. Okay, let's take the case of odd. Okay, there are 4. We need to fill the 4 places. And what are the available digits we have? 2 1s and 2 3s. Okay, so these can be arranged. Let's say these are 4 distinct numbers. Then we have 4 options here, 3 options here, 2 options here, 1 option here. So the number of possible ways is 4 factorial. But here 2 digits are repeated. So the answer will be 4 factorial by 2 factorial into 2 factorial. That is 6. Okay. Similarly for even also, even digits also, we will get similar. Similarly we will get as 6 possibilities. So the answer will be combination of these two, that is 6 into 6, that is 36. Okay, this is time and work problem. Okay, A can do a piece of work in 8 days, B in 16 days, C in 12 days. Okay, 8 starts on Monday. We will write it here, Monday. B on Tuesday. C on Wednesday. Okay, and so on. So next we will work on Thursday and so on. Okay. Okay, what is the LCM of these three things? 48. So let's assume 48 as the total work. Work is equal to 48. So A will complete 6 units in a day. B will complete 3 units. C will complete 4 units. So in a day they will complete uh, okay, what is asked is the work. Okay, A works on Monday, B works on Tuesday, C works on Wednesday, and so on. The work will be finished by Thursday. First statement is Thursday. Okay, let's check how many days they will take. In 3 days, what they will combine 6 plus 3 plus 4. That is 13 units of work they will complete in 3 days. So number of days will be 48 by 13 is 3 plus 9 units, right? So they will take 3 into 3, 9 days, plus for the other 9 units, A will work 6 units plus B will work 3 units. The work will be completed by B. Okay. So the total, this is 9 days, this is 10 days, this is 11 days. So the statement B is wrong. It's given 10 days, but answer is 11 days. So 11 days means 7 plus 4. So if he is working on Monday, by next Monday 7 days will be completed. So Monday, this Monday is 8th day, Tuesday, Wednesday, Thursday, 9th, 10th, 11th. So the answer is Thursday. So statement A is correct, statement 2 is false. So only one is correct. Option A is correct. Okay, next question is Raj has 10 pairs of red, 10 pairs of red, 9 pairs of white, 8 pairs of black shoes. Okay. In a box, if randomly pick shoes one by one without replacement from the box to get a right pair of shoes to wear, what is the maximum number of attempts? Okay. Question is, we have to use the maximum number of times to get the right pair. So what we will do is, first we will pick the other two, that is 9 pairs plus 8 pairs, so 17 pairs we will pick. After that, one pair we will pick from the red. So the answer will be 18 pairs. So that is 36. There are large number of silver coins weighing 2 grams, 5 grams, 10 grams, 25 grams and 50 grams. Okay, the statement that we need to find out whether it's true or false is, to buy a 78 grams, how many one must buy at least 7 coins. Okay, second statement is, you can use less than 7 coins, only one of them is correct. Okay, so if you don't have any time, and if you are facing, if you think you are in, you are not sure if you can clear the exam, there is a 50% probability that either one or two is correct. You can eliminate these two. Okay, so if you think that your luck is good, you can mark this, but it should be taken at your own risk. Okay, so let's try to solve the problem. 78. Okay, if you want to use the less coins, we'll take the maximum value coins first, that is 50 plus 25. The remaining 3 cannot be obtained as there is no 1 gram coin. Okay, there is only 2 grams coin, so this is wrong. Let's take the next possibility. 750 plus, there is no 20 coins, so we'll take 2 into 10 plus 4 into 2. So the number of coins is 1 plus 2 3, 3 plus 4 7. Okay, this is possible, the other case is not possible, so the only option 1 is correct. Okay, this question is 40 children are standing in a circle. 1, 2, 3, so on, so on, so on. There are 40 children and one of them has a ring. Okay. So okay, this one has the ring. Child 1 passes the ring to the child 2, so 1 will give it to 2. 2 will skip the third person and he will give it to 4. 4 will skip the 2 persons 5 and 6 and he will give it to 7. Okay. 7 will skip 3 persons, that is 8 9 10, and he will give it to 11. Okay. 7 8 6 8 9 10. Okay, so on. So when it reaches the first person, what is the number of changes that is took place, that is asked. Okay, let's try to, it can be solved using just writing like this, but it will be, if there are 1000 people you cannot do it. So let's try to find out a solution for this. So let's find the sequence for this series 1 1 2 4 7 and 11. Okay, the second or the difference between these two is 1 2 3 4 5, so on. Okay, this can so if the second term, for finding 2, what we'll do is we'll add 1 to 1. For getting 3, what we'll do is we'll add 1 plus 2 to the 1. So for 4, for okay, for 4 we'll add 1 plus 2. For 7 we are adding 1 plus 2 plus 3. Okay, so this can be written as 7th is the fourth term. So we are adding up to n minus 1. This is 1 plus so on up to n minus 1. So this can be written as 1 plus n minus 1 into n by 2. Okay, so general term of nth term of this sequence can be written as 1 plus n into n minus 1 by 2. Okay, I'm clearing this. So the nth term of this can be written as 1 plus n into n minus 1 by 2. Okay, so he's asking how many times it will take. Let's check for 41. As there are 40 people, this is 1, this is 40. So if we check whether if it is possible in the first case, in the first round itself, 41 is equal to 1 plus n into n minus 1 by 2. That implies n into n minus 1 is equal to 40 into 280. Okay, so this is not possible. Let's take this after one more round. Let's take, so 81 is equal to 1 into 1 plus n into n minus 1 by 2. So we can get n into n minus 1 is equal to 80 into 2 160. This is also not possible. Let's take the third round. 121 is equal to 1 plus n into n minus 1 by 2 plus n into n minus 1 is equal to 240. Okay, this 240 can be written as 16 into 15. So n value is n is equal to 16. That implies number of changes is equal to 15. Option is B. This is a very tricky question. If you have not prior experience, better to skip this question, as it may waste a lot of time in the examination. Okay, the principal P becomes Q in 1 year when compounded half yearly with R% annual rate of interest. If the same principal P becomes Q in 1 year when compounded annually, we know that compound and annually, semi-annually. For same R, we get more amount 1 greater than amount 2 for same R. Okay, so as we in the question, the amount is given as same. The amount is given as same, so the R should, for annually, the R should be greater than the that of semi-annually. So S is greater than R. Okay, if you know this concept, you can directly mark it. If you don't know, okay, let's try it. Let's take one example and solve it. Let's take, for example, when the interest is 10% semi-annually, the equivalent interest, the equivalent rate will be 5 plus 5 plus 5 into 5 by 100. So 10.25. So if you take 10% semi-annually, we'll get 10.25% interest. So in this case, S will become 10.25 and R is 10%. So we can clearly say that S should be greater than R. In this question, we need to find the sum of numbers which are less than 2000 and formed by 1, 2, 3 and 4. Okay, there are 4 digits. Okay, this number is fixed because all should be less than 2000, so we cannot take anything other than 1. For this we have 3 options. Okay, for this we have 3 options. We have taken 1 digit already. We have 2 options for this and 1 option for this. So the numbers we'll get is 1, 4, 3, 2, 1, 4, 2, 3. Okay, similarly 1, 2, 4, 3, 1, 2, 3, 4. Okay, you can calculate like this also, but it will be a very lengthy problem. So let's try to summarize this thing. So if you take second, the hundreds place, for a 100 place, we can take either 4 or 3 or 2. Okay, this will come 2 times. Okay, if we take 4 on the 100 this place, we get 2 numbers for this, so we will multiply with 2. Similarly for 10th place also, we can have 4 or 3 or 2. Okay, that will come 2 times. Similarly for unit digit also. So 4 plus 3 7, 7 plus 2 9, 9 into 2 will take common. You can write 100 plus 10 plus 1, that is 11 into 111. The answer will be we have to add this thousands place sum also. So for how many combinations are possible? 3 into 2, so there will be 6 combinations possible. So we can write 1000 into 1 into 6. So we'll add 6000 to this A. Okay, let's suppose A1. So answer is equal to 6000 plus 11 into 111. So I think we have done some mistake. This is 9 into 2, sorry, 18. This is 18. 18 into 111. So 18 ones are 18. One carry 18 ones are 18. 19, 1 carry. The answer is 6000 plus 1998, that is 7998. Next question. Okay, there are 3 traffic signals. Okay, first one takes 25 seconds, second one takes 39 seconds, third one takes 60 seconds. Okay, from red to green and green to red. Okay, from green to red and red to green. This is 25 plus 25 for first case. Okay, so there will be 50 seconds. Okay, similarly for second one, 78. For the third one, 120 seconds. What is asking it? The duration for the red colors are same. Okay, at 2 p.m. they together turn green. At what time will they change to green simultaneously? Okay, we need to take the LCM of these things, 50, 78 and 120. Okay, and take 10, 5, 78, 12. 6, take 6. You can take 6 common. 6 1 is 6, 6 3 is 6 2 is 5 is. Okay, so the LCM is 60 into 10 into 13, that in seconds. So if we convert it to minutes, it will be 130 minutes. Okay, they simultaneously become green after 130 minutes. That is 2 hours 10 minutes. 2 p.m. plus 2 hours plus 10 minutes, that is 4:10 p.m. Okay, next question. It is given that a plus b plus c plus d f is equal to triple one. Okay, double one double one. Okay, we're saying that non-zero digits. Okay, c plus f is equal to 1. Okay, right, we can write c plus f is equal to 11. Okay, this cannot be 1, this can be 11 only. This one will be carried to the 10th place. b plus c is equal to, this one is carried from unit digit place, so so b plus c will be 10. Similarly, a plus d will is equal to 10. What is asked is a plus c plus d e f. So if we add on the left hand side, we'll get the answer, that is 20 plus 11, 31. Next question. What is the unit digit of the expansion? 57242 into, okay, let's find out the power first. 9 into 5 into 7 into 3, that is 63 into 3, 63 into 15, 45, 4 and 45. We only need the okay, that is, we only need the unit digit, so let's take only the unit digit of this term, that is 2 power 945. That is equal to 945 can be written as 4 into 44, right? So x plus 1. So this can be written as 4x plus 1. So the answer will be 2 power 1. So 2. Okay, I need to find the remainder when this term is divided by 100. Okay, we can see that by 100. So 100 can be written as 10 into 10. So we can find that there is 1 5 here, 1 5 here. So let's cancel out. There is one, there are many 2's in 96. So we can cancel 2 2's. The answer will be 0. As this terms contains 2 5's and multiple 2's, so this will always be divisible by 100. So the remainder will be 0. This is a very easy question. Next question. Okay, there are 4 letters and 4 envelopes. There are 4 letters. Okay, let's try to letter. Okay, there are 4 letters, 1 2 3 4, and there are 4 envelopes. Maybe let's write randomly for easy understanding. Okay, these are the envelopes. Okay, if the letters are randomly inserted in the envelope, then consider the following statements. It is possible that the exactly one letter goes into an incorrect envelope. For example, let's for the first statement we'll discuss. If we put 1 into 3, okay, you cannot put 3 in 3. So this will also go wrong. If one goes wrong, the other goes wrong. So if it is not possible for one envelope to be put wrong. So the first statement is wrong. So what is the second statement? There are only 6 ways in which only 2 letters can go into the correct envelopes. Okay, let's find out the possibilities. Okay, 2 can go wrong means 2 right, yes, 2 wrong, 2 right, 2 wrong. Okay, two envelopes can go right only in one way, that is you can put 1 into 1 and 2 into 2, that is only possibility. So there is one way. Okay, you have to put 2 wrong. Okay, but you can select these 2 out of the 4, so there will be 4 C2 selections. Okay, that you can put in one way. The other 2, if you take, already you have taken 2, so there the other remaining and letters can go wrong only in one way. That means, for example, if you have 1 and 2 letters and 1 and 2 envelopes, you can put wrong only in one way. This way only you can put wrong, so there will be only one way. Okay, into 1. So 4C2 is 4 into 3 by 2, that is 6 ways. So the second option is right, only 2 right. Next question is, how many ways can a batsman score exactly 25 runs? Okay, we can write total number of runs is equal to x plus 4y plus 6z. X is the number of singles, y is the number of boundaries, that is the number of sixes. Okay, as x is z has the highest value, we'll start with z. Okay, for z is equal to 0, we can have y can be 0, right? Y is equal to 0. Let's write y here, z here, x here. Okay, y can be 0 and x can be 25. Okay, y can be 1 boundary, 1 4. Okay, so the remaining 21 runs will be scored in singles. 2 boundaries 17, 3 boundaries 13, 4 boundaries 9, 5 boundaries 5, 6 boundaries 1. So there are 7 possible ways for this z is equal to 0. Okay, similarly for z is equal to 1, y x, y can be 1, so 10 runs is scored in boundaries and the remaining 15 in singles. 2 boundaries 11, 3 boundaries 7, 4 boundaries 3. Okay, so the number of possible values for z is equal to 1 is 4. Okay, for z is equal to 2, y x 1 0 boundaries, so other 13 will be in the form of singles. 1 boundary 9 singles, 2 boundaries 5 singles, 3 boundaries 1 single. Okay, so here also there are 4 possible cases. 2 6s is 12, 3 4s is 12, 24 plus 1. Okay, right. Okay, for z is equal to 3, we have y is equal to y is equal to be 0, so 3 6 18 7, 1 boundary 3 runs. 2 possibilities, z is equal to 4, only 1 single is required, x is equal to 1. So the number of possible cases is 7 plus 4 plus 4 plus 3 plus 2 plus 1. No, there is no 3. 7 plus 4 11, 11 plus 4 is 15, 17 18. The answer is 18. This is also a lengthy question, but as this paper is qualifying, I think we can easily qualify, but it is very difficult to get a very good score in this paper because the paper is very lengthy. Okay, next question is PP, QQ, RR are 2-digit numbers. Okay, and P less than Q less than R. This is also a very lengthy question, but we will try to solve in the least possible way. PP plus QQ plus RR is equal to TT0. Okay. Okay. is saying that p plus q plus r is equal to 0. P plus q plus r is not 0. It can be 10. This is the one case. First case it can be 10. Second case p plus q plus r is equal to 20. This is another case. Okay. For case 1 we'll try to find out the values of p plus q plus r. Okay. So let's try to find out the value of t first. T can be either 1 or 2, cannot be more than that, right? Because p, q, r are single digits, their sum cannot be more than 30. So the either t is equal to 1 or t is equal to 2 is the only possible case. For t is equal to 1, p plus q plus r will be 10. Okay. For 10 values we can write, for example, we need to take p less than q less than r. In such manner we have to take. So pqr is 10, so we can take as 3, 3, 4. Okay. This combination is not possible as it is said that p less than q less than r, but here p equal to q, this is not possible. So we'll just make some changes in this. So we'll reduce minus 1 here, right? We'll reduce minus 1, that is 2, 3, 5. This is a valid possible combination, right? Similarly we can go for 1, 3 and 6, right? We can also go for 1, 2 and 7. That is also possible. We cannot go for 1, 1, 8 because that will be p is equal to q. Let's try to increase the value. 3, 4 and 5 is not possible. Okay, let's for p is equal to p plus q plus r is equal to 10. We have 3 possible values, right? Okay. Let's find out the values for p plus q plus r plus is equal to 20. 20 by 3 is 7. So we'll write around 7. 6, 7, 7. Right? What we can do is 5, 6, 9. This is wrong. This is right. Okay. 5, 6, 9 is possible. 4, 6, 10 is not possible because this will be a double digit then. So we'll write 5, 7 and 8. That is also possible. We can write 4, 7, 9. Right? 4 plus 9 is 13. 30 plus 7. Right? 4, 8, 8 is not possible. Okay. So how many values we got so far? Okay. I think we have finished. Is there anything left? 5, 8, 13, 7, not possible. 5, 7, 8 is right. We have written. So here there are 3 possible cases. Let's check the statement 1. The number of possible values of p is 5. 2 plus p can take the value of 1, 2, 4, 5 and 6. So the statement 1 is correct. Let's check the statement 2. Q can take 6 values. 2, 3, 5, 6, 7. Statement 2 looks something problem with the statement 2. Okay. I think you can try. The method is this method. You can try. I think the answer is both. Not able to find someone. Okay, you can try at your. Okay, you can try at your home. Next question is p plus q plus r minus p plus q minus r is greater than p minus q plus r, where p, q are integers. Okay, it said that p plus q minus r minus p minus q plus r is equal to, this is greater than 0. Okay, p is cancelled out. Q minus q is 2 into 2q minus 2r is greater than 0. That implies q minus r greater than 0. Okay. What is given in the question is, which one of the following is correct in respect to the above questions and statement. Question can be answered by using one of the statements alone. If p minus q is positive, okay, let's I think the question cannot be answered. If this statement is given, q minus r is greater than 0, then we can say that the above statement is correct. So the answer will be 4. Next question is, p is a prime number, q is a composite number. So what is given is p plus c by p minus c can be even. Okay, let's take p is equal to 9, prime number, p is equal to 11, p is equal to 11 and c is equal to 9. Okay, so p plus c will be 11 plus 9 by 11 minus 9, that is 20 by 2, 10. So this can be correct. 2p plus c can be even. 2 into prime number. Okay, 2p plus c can be odd, right? Okay, 2p, let's say p is equal to 2, c can take as 9. So this is also correct. 9 plus 4, 13. 13 is odd, right? Second statement is also correct. P into c is odd. Prime number, let's take 7. 7 into composite number, we can take 9. 7 9 is 30, 63. That is also odd, right? So all the statements 1, 2, 3 are correct. Next question, D is a three-digit number such that the ratio of the number to the sum of digits is least. Okay, we is given that x, y, z is a number. When it is divided by x plus y plus z, this is least number possible. Okay, we know we can write x, y, z as 100x plus 10y plus z by x plus y plus z. This will be least if you, when you maximize the value of z, it should be max and it should be minimum, right? But x cannot, you cannot take 0 because it will become a two-digit number. So we will take x is equal to 1, y is equal to 0, z is equal to 9. So the answer will be 109 divided by 10. 1 plus 9, that is 10, 10.9. What is asking is difference between the digit at the hundredth place and digit at the units place. Difference between 9 and 1 is 8. So answer is C, 8. Okay, there is a sequence. We have to fill that sequence. Okay, we have to fill the pattern. A, B, C, D. Let's find the number of terms. 5, 5, 5, 5. There are 25 terms. So we'll split into 5 into 5. 5, 5 5s will split. Okay, we can see that A, B, C, D should come. So these two can be eliminated. We take D. Let's check for the option C and D. Okay, let's check with C. It is not matching. Okay, let's check for D. It is matching. A, B, B, A, B, C, D, D, A, B, C, C, D. Okay, it is coming A, B, C, D, D, D. Okay, A, B, C, C, D, right? In first term, D is repeating. In second term, C is repeating. In the third term, B is repeating. In the fourth term, A is repeating. Okay, so the answer is D. Okay, it is said given that A, B, C, D are two-digit numbers. A, B, C, D are two-digit numbers. Multiplying A, B with C, D results in a three-digit number D, E, F. A, B into C, D is equal to D, E, F. Okay, very nice. Adding D, E, F to another three-digit number G, H, I. results in 975. Either A, B, C, D, F, I are distinct digits. If E is equal to 0, F is equal to 8. Replace E is equal to 0, F is equal to 8. What is the value of A plus B plus C? Okay, right. G, H, I. Okay, 975. Okay, I can take value of 7, right? There is any other possibility for I must be 7. I don't think any other value is possible. Okay, we can write how many digits are there. A, B, C, D, E, F, G, H, I. So there are 9, right? We'll write here A, B, C, D, E, F, G, H, I. I can take only value of 7. E is given as 0. F is given as 8. Okay. Is 7, 15. So 0 plus h is equal to 0 plus h plus 1 is equal to 7. So h can take the value of 6. Right? Is there any possibility of other than 6? No. H will be 6. Right. So d plus g is equal to 9. We can get as d plus g is equal to 9. Okay. We have possible combination is 5 4 can be d and g, right? 5 4 1 8 is not possible. 0 9 is possible. Okay. dg can be 2 7 is not possible because I is 7. 3 6 is not possible. 4 5 d comma g can be 4 comma 5 or 5 comma 4, and 7 2 is also possible, right? 7 is already taken by I, so not possible. So only possibility is 4 and 5, right? dg is 4 and 5. Right, let's go to, okay, what is given? AB into CD is equal to DEF, right? AB into CD is equal to DEF. EF E0 8, right? Okay, B into D should be 8. So D can be 4, right? D is 4, G is 5, D is 4, G is 5. So B can take only value 2. Okay, B is 2, D is 4. Okay, 408. AC, we are left with AC, right? What are the possible options for A and C to get a value of 408, right? 92 into 34, 27 plus 3 plus 6. You are left with A and C. Uh, okay, let's check for 93, 92 into 34. A2 into C4 should be 408. So A can take, we can check for 12 into 14, 12 into 34 or 32 into 14. So this option fits for 408. So A is 1 and C is 3. So the what is asked is A plus B plus C. 1 plus 2 plus 3, that is 6. A is the right answer. This is a lengthy question. Better to skip this in the exam. Next question is, I think we have already done this. The answer is we got 15, right? Okay. Next question. How many natural numbers are there which give a remainder 31 when 1186 is divided by these natural numbers? Okay. We have to divide 1186 by x and we should get a remainder of 31, right? Okay, we'll remove the remainder 31 from this. So this should be divisible by x. So we'll find the number of factors of 1155. Okay, the number of factors will be 5 power 1, that is 1 plus 1 into 1 plus 1 into 1 plus 1 into 1 plus 1, that is 16. But these factors should be greater than 31, otherwise the remainder will be less than 31. So we'll remove the factors which are less than 31 from this. So the factors less than 31 are 1, 3, 5, 7, 11, 15, 21, 33 is more than that, so that will exclude 21. How many so far? 4 plus 3, 8. So these are the values which are factors which are less than 31. So the remainder will be less than 31 in these cases. When it is divisible by 3, 5, 7, 11 or 21, the remainder will be less than 31. It will not be 31. So the answer will be 16 minus 8. For 8 factors, the remainder will be 31. Okay, thank you. I think its paper is lengthy, but you can skip the difficult ones and you can solve the easy ones. There are many easy questions also. For the next exam, all the best. Thank you. We'll meet again. Please subscribe the channel if you like the content.